So in this video, we look at something called pressure. Now, previously, when we've done our dropping a parachute task and when we've looked at things like buoyancy and floating, we've actually looked at pressure. So pressure is when a force acts over an actual area, and providing that force provides pressure. To get an idea of what pressure means, you can make a fist with one hand, press it as hard as you can into the palm of the other. Now, inside of a fist, use one straight pointing finger and press as hard as you can into the palm of your other hand. What you'll notice is that the finger pressed into the palm and the fist pressed into the palm use the same force. So if you press your full fist into your palm, you're applying a particular force. And then if you try and press using just your finger, you're actually applying the same force with your arm, but the finger press actually hurts quite a lot more. That's because you're using just the tip of your finger, which is a much smaller surface area, to apply the same force as you are with your full hand. So because it's a smaller surface area, it's the same force over a smaller area, so it's a greater pressure. So pressure depends on the size of the force and the area over which you apply it. We've actually got an equation for finding pressure. So pressure is the force divided by the area. When we looked at gravity, mass, and weight before, we said that weight was gravity multiplied by the mass. So that gave us a triangle with weight at the top and gravity and mass as the two holding up pillars at the bottom. We have a similar equation with pressure, force, and area. This time pressure is at the top of our triangle here, and pressure, what am I saying? Force in newtons is at the top of our pyramid here, and pressure and area in square meters are at the bottom of our pyramid. What that means is if you want to know the pressure that's being applied, you look at the force and you divide it by the area in meters squared that is being pushed across. So pressure in pascals is what we measure this in. There's an old joke that famous scientists Isaac Newton, Einstein, and Pascal are playing hide and seek. And Einstein is the seeker, so he closes his eyes, and Pascal goes and hides behind a bush, and Newton walks into the middle of an open area and draws a square around himself 1 meter by 1 meter. So Einstein uncovers his eyes, is a bit confused, and goes over and taps Newton. And he says, "Newton, I found you." And he says, "No, you didn't. You found 1 Newton per square meter. You found Pascal," which is obviously a hilarious physics joke. So a Newton per square meter is a Pascal. So I'll put up a video about crushing a can. This is a shame. The can crush demo is actually really, really cool. You can do in class where you look at balancing forces and using Bunsen burners to crush a can. It's very cool. In your jota, I would like to try and answer these questions. So can you calculate the pressure when a force of 20 newtons pushes on a surface with an area of 1/2 a meter squared? Remembering that the equation we're using is the pressure is the force in newtons divided by the area in meters squared. And which of these blocks will have the biggest pressure on the floor? Explain your answer. So for this one here, think about force, think about mass, and think about surface area. So a clue would be, look at this distance. Is it bigger or smaller than this distance and this distance? And again, this one and this one. You might notice they're probably about the same width and depth, but it looks like this one is higher. So think about which one's going to have the highest weight, and then look at which ones have different surface areas and which ones have the same surface area touching the ground. A clue would be they don't have the same, even though these two have the same surface area touching the ground, they don't have the same pressure. In question 2, so that's this one, it tells you that this block has a mass of 2 kilograms and a surface area of 0.2 meters squared, and it asks you to calculate the pressure it pushes on the floor with. Then I want you to use your knowledge of forces and pressure to design and make a parachute using newspaper. This is very similar to what we did before with our sheet of paper. Anything you have at home, if it's not newspaper, straws, plain paper, sellotape, that's okay. Anything you have, try and make a parachute, and then underneath your parachute, see if you can attach something. So think about, what will I need to do if I basically want to make it so that there is the lowest possible force being applied to the ground. So think about it. How can you make a parachute so you probably maximize the surface area? So your teacher will tell you if your parachute is good. So if you upload a picture or you upload a description, I will tell you if your parachute is good. What you can then do is, again, in your jotter or on a piece of paper, have a look at these questions. What are the units for the following terms? So what's the unit for mass, for force, for weight, and for pressure? Calculate the weight of this block of cement. So its mass is 35 kilograms. What would its weight be on Earth? And the block of, if you can't remember the gravity constant, you can Google it. I think it's about 9.75. The block of cement has a square bottom, so it's the same on all sides at the bottom. And each of those lengths is 2 meters. So think about what meter squareage will that be, and then think about what the pressure exerted on the floor would be. Next lesson, you'll look at electromagnetism with Miss Dick. Hopefully that makes sense. Please do ask if you have any problems.